afternoon. Assalamu alaikum. Ladies and gentlemen, at the outset, thanks to the chairman for the elaborate description of my profile. I think, like most of you in the room, been all through my life an oil and gas person. Worked only for oil and gas, no other sector. Joined a refinery and then moved on to upstream and then now with the integrated oil company. As you know, ENOC is the premier oil and gas company owned by the government of Dubai, has interests in upstream, midstream, and the downstream. And we operate in 3 continents, in about 10 countries, if I include the exploration interest. So that's the company background, and I thought I would share one of the issues that we face in major projects, in billion projects, is how do you manage integration of HSE into designs? The biggest problem we face is that either we are involved too late in the project or not at all involved in some cases. Even if they're involved, the right personnel are not involved. So you find various issues coming up once the project is commissioned, up and running. You'll find reasons to again take a shutdown to improve certain features which are not designed in, not built in. And we are talking of millions of dollars, loss of revenue by shutting down plants. Now, let me go through the project lifecycle to begin with. You have different stages, right from the appraisal to selection, defining it, executing, and operating a project. And some of the companies do include abandoning, especially the upstream. Abandoning a well, especially offshore, is pretty expensive. So we include the abandonment also as part of the project lifecycle. But let me confine to onshore projects where we focus on up to the stage of operations. The challenges that we come across are typically related to process safety and also to the management of construction activity. These 2 are major, but there's one which is common to both, is the road safety. Again, when you build a plant of a huge investment, you're talking of movement of goods, heavy objects, over-dimension objects that would need a lot of planning. And if you look at oil and gas, especially the upstream statistics, about 40% of the fatalities are on the road. Not a small number. I'm talking of dozens of people getting killed all over the world in the transportation side. Now, the reason why we are concerned about integration of HSE is for one reason, that quite often we don't learn from incidents. So if you built a plant, world-class plant, and you operated, something like 60 million man-hours without a lost-time injury, and I am planning to build a similar plant, there's big gap between these 2. We don't learn lessons. Again, set the clock back and start from scratch to design my own process. Quite often in the industry, we find that the memory of organizations is very short, right? And similar type of incidents happen at different facilities of the same company. The third one is a past incident is the cause of a future accident because we haven't fixed the problems, we haven't fixed the root causes. So the management guru in HSE, especially the safety side, Trevor Clegg, I quote from his book that the similar incidents can be prevented in future if we know what's gone wrong. But unfortunately, the history of process industry show that many incidents repeated after a lapse of few years because we don't learn lessons. Now, the integration, when we speak about different phases of project, are essentially for the reasons, number 1, you want to have inherently safe design. Number 2, you want to engineer safety right from beginning. And number 3, You want to operate it safely, so you have a procedural safety. A lot of people spoke about SOPs. I've seen Gail's, the video animated version of a operating procedure. So if we can think all this ahead and develop systems right from day one, even when you're conceiving a project, I would see that as a highly successful integration. And the benefit of it is that you don't have to rework much. You don't lose revenues once you start operationalizing it. And number three, you won't kill people, perhaps. That's one major difference between a planned and unplanned execution of projects. Now, I also heard a lot of project managers complaining. Personally, I used to receive complaints that your engineers are asking for too much. They want gold plating, right? They want so many systems that, this project is not viable. When I say project manager, I'm talking of the project manager who has the DOA to spend money. And when you have the project meetings, right from beginning, they come up with saying, look, the HAZOPs too many HAZOPs have been done. They're asking too many layers of protection. These kind of critiques or the feedback from the project managers is quite genuine. If you look from their perspective, they got a limited budget, and they don't want to overshoot the budgets. On the other side, we are wearing a safety helmet, safety hat, and we want to have the best of the best systems with all those features, various layers. Now, how do we strike a balance? So we can't drop completely. At the same time, we can't demand too many layers, unreasonably too many layers. Now, there are also cases where there are changes made too late, too many changes. And I've seen cases where people rushed too fast to commission because they already overshot the deadlines. So there's a lot of pressure from the commercial guys that you must start selling now. The gas plant the power plant is waiting for the gas. You got to turn on the equipment, the compressors, start pumping gas to the gas plant, to the power plant. Now, those pressures, the commercial pressures, also take its toll on HSE, on the quality of HSE in design. And some companies struggle with, ad hoc review process. That means if I'm the project manager and I have a good relation with the HSE manager, we work together, so I keep asking them, can you help me? I'm doing this. At times I might ignore. It's a matter of convenience. If it suits me, I would ask for. If it doesn't suit me, I wouldn't even ask for HSE guys to come in. Quite often, after all, we are human beings. Their human relations play a role in the integration of HSE in projects. Quite often, we tend to have these personal issues coming into projects. Now, the poor integration, we spoke about the late, intervention in the projects. Also, lack of proper management of change. Poor rule set. We don't have the SOR, the statement of requirements, well defined. Yeah? So we struggle with very vague, ambiguous requirements from HSE. Also, the competency in process safety. Honestly speaking, we still don't realize, except few engineers, the importance of putting the right balance of safety, instrumented safety systems, right? Or safety instrumented systems, SIS. Now, how many are proficient in SIL? We depend on consultants. And today, I come across consultants who are probably about 30, 32 years, 35 years, with hardly 5, 6 years experience, may not be even relevant experience, but those guys, recommend certain layers, and the process owners accept that on the face value. You can imagine what happens in terms of the costing, in terms of the operational difficulty at a later stage. So I think the industry as a whole is also suffering from lack of competency in certain areas of process safety. I wouldn't say entire process safety, but certain segments of it. So now I refer to the integration in a systematic manner, which would lead us to successful commissioning and operation of plants. There are, you can see on this particular slide, a number of stage gates defined, right from number 1 to 7, 7 different gates. This is for a typical upstream project where abandonment is the last stage. Now, each of the stages have got project HSE reviews. I'm sure most of you are familiar with phasers. We call it short-term phaser, project HSE reviews. The review starts right from the concept stage and goes on until abandonment with different focus each time we look at the intent of the phaser. And the composition of phasers is also very, very important. At each stage, you need a kind of different skill set. So we got to pick up members who have hands-on experience in that particular phase. There could be some commonality, maybe phase number 3 to 5, you could have a common team who understands because they're watching they vetted the design, they go to the field, they cross-check the execution part of it and until it's commissioned. So the suggested model for optimal HSE review is given over in this particular slide. I mean, who is involved, what are the tools that we deploy, and what are the key objectives of each of these phases. Right from the concept, feed, detailed design, construction, pre-com, and commissioning and startup. Now, this is a suggested model. I'm not saying this is the model, but I think when you look at various options available, you could perhaps look at this as one of the models. And you can, the beauty of this particular model is it's totally flexible. You can decide when you want to do the HAZOPs based on the complexity of your project. Some people might want to choose HAZOP at every stage, which means there are as many as about at least 5 HAZOPs on the same project. I've known of companies who have done HAZOP only once. When? That was at the detailed engineering design. I got the set of drawings, I divide into nodes, hundreds of nodes, call consultants, get our ops and maintenance engineers and HSE engineer, and then start the HAZOP process. Once that is done, that's it. For the whole life, only one HAZOP. But there are too many dangers of doing one HAZOP and proceeding. The reason being, when you designed, a few days after that, one of these engineers would like to have a better way of operating it. So they would ask for a small change. One node changes, and that node change could impact rest of the interconnected nodes. During construction, contractor says, I can't procure this material. The lead time is 8 months. Do you want to wait for it? Obviously, nobody would wait for 8 months unless it's well planned. So you want to go for an alternate tool or system, thereby the intent of HAZOP changes again. So HAZOP has got to be done at least 3 critical phases: at the feed design, at the detailed design, and during the construction, and sometimes RFSU, ready for startup. Before ready for startup, just cross-check as built versus design. Are there major changes? Did I cover all the risks? So that's something on the HAZOP. I would now take you to a case study. This is the most important part. I've got another 3-4 minutes, but I think I would rush through a project. This is a live, today operational project, commissioned in 2009, $4.2 billion. The time given to execute was 24 months. I've seen one of the kind of fast-track projects executed with that vigorous timeline. And all the gates were implemented in this particular project, right from the concept to implementation. Still, this case study will show you what could be pitfalls. Right. You could see some examples here. I'm not sure whether you could read there. It's a slug catcher. It's an upstream company. So the first part is the crude, oil, and the sediment. Everything comes together, water, oil, and gas, into a slug catcher. It settles there, and you separate out, gas breaks out, you separate out the oil, and then the crude moves to the next one further for dehydration. There is an IR. This is a high pressure. You're talking of about 90 bar pressure, right? Pretty high pressure. And so there are IR detectors provided in case of any gas release from these vessels. there is an extensive network of IR systems provided, infrared detection. But they were given a wrong direction completely. They wouldn't cover the escape. And it's blocked by concrete, what you call pedestals. And if you look at the next one picture, there is one weld that is done at heat-affected zone. You could see carefully there is a weld done. After the design is frozen, in the field, the operations wanted a modification, and this is how they've done in the heat-affected zone. The whole component became invalid from quality point of view. So you got to redo the whole thing. And it takes nearly about 3 to 4 months to get back the component. And you're talking of another 3 days to go for commissioning, right? Last minute changes. And the other side is a tank farm. They want to take the crude into the tank, but the dike wall is broken. The contractor is doing some work which was forgotten earlier. So they rush back. The equipment cannot go in. You got to break the dike wall. So there's no impounding anymore. So these are serious lapses that would happen if it's not carefully planned. And the worst of all is yet to come. This is a gas pipeline I'm talking of about 700 kilometers long. And at the last 30 kilometers from, that means around 600 odd kilometers, there was a venting system given, high pressure gas line venting system. And the vent was given as an open vent, where the design was to go back to a flare line, cold flare line. So the relief system was not fully executed as per design. And this was detected by the RFSU team. The ready for startup team of about 6-7 members detected, and the pipeline was to be commissioned within few days from that inspection. Press was notified. Everything ready, customers were told. And now you wouldn't really want to put the gas into the line. Why? You can't shut down the pipeline to re-weld the whole system, relief system. So you got to either do it then and there, otherwise you live whole life with the risk of having an explosion on the gas pipeline. So this is something that pulled back the project further by a month. The project was delayed by a month. I'm talking of revenues of per day maybe about $3 to $4 million net profit per day into a month. So that's money lost. But I would say in a way, it is probably $1 billion saved. If it was commissioned with that defect, yeah, now you take a call, cost-benefit kind of a call, that $90 million is lost, but we could have potentially lost $1 billion. What do you prefer? So these are challenges you find in a big project. Unless we integrate carefully and keep checking, have a third party to review your phasers and your stage-gated process. At end of the day, it's all about saving the operational downtime post-startup. You don't want to shut down even a day once you commission it. That's the ideal project execution completion. The good thing in this project was about 42 million man-hours LTA free. So there are positive things in the stage-gated process, as I was explaining earlier. You would definitely be very, very good on safety records, and this is what was outcome. And then no tier 1 process safety incidents since startup. That is another measure of success. But then all those defects I've mentioned were detected by the stage-gated process, because there was the independent inspectors going in various phasers and RFSU. These guys could pick up those lapses and in time saved probably a lot more losses, both in terms of revenues and loss of lives. So thank you very much. That brings me to the end of my presentation.